Hello everyone. Today we are going to learn a little bit more about the H2S gas sensing or the crucial role of H2S gas sensing. To detect this H2S gas, we are going to utilize the chemiresistive metal oxide gas sensor. Not only the detection, but it is also important to fabricate an easily portable sensing device that can work at low temperatures. To understand why this H2S gas is so important and lethal, the permissible exposure limit by OSHA for this gas is 20 to 50 ppm. That means a body can have severe effects on their health and even death if it is exposed to more concentration of H2S gas. This gas is a colorless, flammable, poisonous, and corrosive, which is mostly noticeable by its rotten egg smell. This hydrogen sulfide gas is commonly found during the drilling and the production of the crude oil, natural gas oil. It is also found in a little bit of concentration in wastewater treatment and utility facilities and sewer plants. This is because of the organic matter that is going to be reduced by the enterobic sulfate bacteria, which releases the H2S gas. Moving forward with the behavior of utilizing the copper oxide decorated SnO2 nanofibers towards the H2S gas, we have utilized the electrospinning process to fabricate the SnO2 nanofibers. These nanofibers were further decorated with copper oxide material for different duration of time. For a better understanding, if the material is exposed to the atmospheric oxygen, there is a certain amount of baseline resistance attained by the material. This, when upon the exposure to H2S gas, the resistance decreases down to a certain level, which is also known by Rg. When the H2S gas is released out, the resistance goes back to its normal position. The change in the resistance is also known as response, Ra, which is equal to Ra minus Rg divided by Ra into 100. There are other parameters such as response time, recovery time, selectivity, and limit of detection, upon which we can say whether a sensor is reliable or not. The studies were carried out with different types of material, but the SnO2 has slightly been used as a gas sensor due to its low cost, higher chemical sensitivity, faster gas response, and good stability. We expose the material SnO2 as well as the SnO2 decorated copper oxide for different concentration of H2S gases. We have observed that there is a response of 60% for 50 ppm of H2S gas when bare SnO2 nanofibers were exposed to the H2S gas at 200 degrees Celsius, upon which we decorated the copper oxide material for 60 seconds and we have observed an elevation of response of 85.6%. We further increased the copper oxide decoration and saw that there was a decrease in the response, which was further lowered down to 61% for 50 ppm of H2S gas at the same operating temperature. To understand why this is happening, the hydrogen sulfide, when reacts with the material, it breaks the p-n junction between copper oxide and tin oxide. The material is also been changed from copper oxide to copper sulfide upon reacting with the H2S gas. This copper sulfide is little bit more conductive in nature than the copper oxide, because of which there is a more supply of electrons to the material, which also gives the more active sites for the reaction to take place. We have also concluded with it with a radar plot. There is a comparison between 30, 60 and 90 seconds of copper oxide decoration, and you can see there is a more response towards the 60 seconds of decoration that was taken place. Our work also concludes that there is a response which is elevated only for H2S gas compared to the other gas, which also says that the material plays an important role in detecting the H2S gas. Here are the few scientific contributions from my papers, and if you are more interested, you can scan this QR code and you can read more about the detection of H2S gas via copper oxide decorated SnO2 nanofibers. Thank you.